Have you ever wondered why data centers don't just use a single network cable between devices? It sounds simple, right? One cable connects the server to the switch and everything works. But what happens if that cable fails? Or what if one cable simply isn't fast enough anymore? Modern data centers can't afford downtime. That's why engineers use Port Channel and vPC. These technologies provide more bandwidth, higher availability, and almost zero downtime. In this episode, I'll explain everything from the basics to real Cisco Nexus implementations in a simple way. Let's get started. Imagine you have 4 highways between 2 cities. Instead of using only one highway while the others stays empty, traffic can use all of them together. That's exactly how a port channel works. A port channel combines multiple physical Ethernet links into one logical interface. To the devices, it looks like a single cable, but behind the scenes, multiple cables are carrying traffic together. The benefits are simple: more bandwidth, better redundancy, easier management. Instead of configuring 4 interfaces separately, you configure only one logical interface. Now you might ask, if there are 4 cables, does every packet go through all 4? Actually no. A single conversation or flow always stays on one physical link. The switch uses a hashing algorithm based on information like source MAC address, destination MAC address, IP address, sometimes layer 4 ports. Different traffic flows are distributed across different member links. So one user might use link 1, another user uses link 2, a third user uses link 3. This allows all links to be utilized efficiently without packets arriving out of order, and if one link fails, the switch automatically moves new traffic to the remaining active links. There are 3 common ways to build a port channel. Static mode. This is completely manual. Both switches are forced into the port channel. No negotiation happens. It's simple, but there's no verification that the other side is configured correctly. LACP stands for Link Aggregation Control Protocol. It's the IEEE industry standard. Devices exchange LACP packets to negotiate and verify the connection automatically. This is the recommended option for Cisco Nexus switches and modern data centers. PAgP stands for Port Aggregation Protocol. Unlike LACP, it's proprietary to Cisco. It's mainly used on Cisco Catalyst switches. You'll rarely see it in modern Nexus environments. LACP has only 2 modes. Active. Active devices initiate the negotiation. They send LACP packets immediately. Passive. Passive devices wait for the other side. Here are the combinations. Active plus active works perfectly. Active plus passive also works. Passive plus passive, nothing happens, because neither device starts the conversation. So remember one simple rule: at least one side must be active. PAgP works similarly. It has 2 negotiation modes. Desirable starts the negotiation. Auto waits for the other side. Desirable plus desirable works. Desirable plus auto also works. Auto plus auto does not. Again, someone has to initiate the negotiation. Although PAgP still exists, LACP is the preferred option today because it's an open standard and supported by many vendors. Let's compare port channel with individual links. Imagine 4 separate cables. If one cable fails, you immediately lost that bandwidth. Traffic may also need to reconverge. Now imagine those same 4 cables bundled into one port channel. If one link fails, users usually don't even notice. Traffic simply continues across the remaining links. That's why port channel provides higher bandwidth, better redundancy, load balancing, simpler management. One common misunderstanding is that every packet travels across every cable. That's not true. Instead, each traffic flow is assigned to one member link using a hashing algorithm. For example, user A may always use link A1, user B uses link 2, user C uses link 3, user D uses link 4. This keeps packets in order while allowing many users to share the available bandwidth efficiently. If a link fails, the switch recalculates and redistributes traffic over the remaining active links automatically. Now let's move to one of Cisco Nexus' most powerful features. vPC stands for Virtual Port Channel. Normally a port channel connects to only one switch. But what if you want a server connected to two different switches at the same time? Normally a spanning tree would block one of those links. With vPC, both switches appear as one logical switch to the connected device. That means both links stay active. Traffic can use both links simultaneously. And if one switch fails, traffic continues through the other without interruption. This is called active-active redundancy. For a stable vPC deployment, Cisco recommends a few best practices. Always keep the peer link healthy. Use LACP for downstream port channels. Keep VLANs and trying configurations identical on both switches. Monitor the health of both peer switches regularly and test failover scenarios before putting the design into production. These small steps make your network much more reliable. Where is vPC actually used? Almost everywhere in modern data centers. Servers can connect to two switches simultaneously. Storage or arrays benefit from high availability. Hypervisors like VMware ESXi avoid blocked link while maintaining redundancy. Private cloud and virtualization platforms rely heavily on vPC for active-active connectivity. The result is better performance and fewer single points of failure. Let's quickly review what we've learned today. A port channel combines multiple physical links into one logical interface. It provides more bandwidth, redundancy, load balancing, simpler management. LACP is the recommended protocol for modern data centers. PAgP is Cisco proprietary and mostly used on Catalyst switches. And finally, Cisco vPC allows two Nexus switches to act as one logical switch, providing true active-active connectivity with no blocked links. These technologies are the foundation of resilient, high-performance data center networks. I hope this video helped you understand port channel and Cisco vPC much more clearly. If you enjoyed this episode, please give it a like, subscribe to the channel, and turn on notifications so you don't miss the next lessons. In the next episode of the Data Center Fundamentals series, we'll explore switch virtualization, including VRF, VDC, and how logical separation is used in enterprise data centers. Thanks for watching, and I'll see you in the next video.